Positive.
Right. So I will graph the unit circle right away and then identify the quadrants in which sine is a positive number.
It's 1 and 2.
1 and 2. His memory is bad, by the way. Okay, so it is 1 and 2. So now I'm asking myself, which angle has sine? Okay,
I'm sorry.
that's good. So that's 60 degrees. So this is the measure that I'm looking for, right? So because sine is measured on the y-axis, this piece corresponds to two angles. To this angle, which indeed is 60 degrees, or pi over 3, and to which other angle?
300.
Right here. What is the reference angle, which is this? What is the reference angle for that? Oh, it must be 60 degrees. So then what is this? First angle is 60. What is the second angle?
First angle is 60 would be 180 minus 60.
Exactly. So this will be 120 degrees. So there are two solutions. Basically infinitely many, but two different ones.
You do plus
Yes, I will.
2 pi k.
2 pi k. So x equals and x equals. If I write here 2 pi k, I have to write the angle in radians.
So it's pi over 3.
Indeed.
And
You can say pi minus pi over 3. Pi minus pi over 3, I have to find the least common denominator, which is, there is only one denominator. And I multiply this by 3, so 3 pi minus pi is 2 pi.
or you can do 120 divided by 1.
So this is what 120 degrees is double of that. So if this is pi over 3, double will be 2 pi over 3.
Then if you math fraction.
And I have to mention that k is 0 plus or minus 1 plus or minus 2, so we know what k represents.
This is what I've been doing for the ladder angle. Do 120 degrees.
Minus the reference angle.
Because you multiply it to convert it to radians.
Right, so it's
you
pi.
divide it by
180. So it's pi.
And it comes out as a fraction, as a decimal, and then change it to a fraction, and it comes 2/3. So it's 2 pi over 3.
That's good.
That's what I was starting.
Other questions? Is there anything else? Is there anything else you would like to ask? Yes, please, Krishna.
For the x equals, does it matter? Because I presented it another way where it's like plus 360 degrees.
It's the same thing, because 2 pi is 360 degrees. But if I write here pi, I have to write here pi. If I have here radians, I have to have here radians. So the other option is x equals 60 degrees plus 360k, which is the same thing. Pi over 3 is 60 and 2 pi is 360.
Okay, so as long as you keep the two the same, it doesn't matter which.
It doesn't matter. It's the same thing.
Okay.
Yep. Good. Is this okay? All right. Other questions? Other questions? Okay, so this is what we started with actually. However, I cannot solve this problem in the same way because I have no idea what angle has sine 0.7. So in this case, I had to apply the inverse function and put it in the calculator. So we solved and we looked at some other problems with, for example, tangent pi over 2. And that little chart does not contain tangent. I never asked you to memorize tangent, and you shouldn't. But you know that tangent pi over 2 is sine pi over 2 over cosine pi over 2. Pi over 2 is right here, You know that cosine, which is measured on the x-axis, right, it's 0, so then the bottom is 0, and sine is 1, so it must be undefined. I strongly recommend do not memorize anything else but the numbers that I gave you. There is no
You
need.
expect us to remember the values of sine and cosine, 30 degrees, 45 degrees.
That's it. Of course, and the points on the unit circle, because those are the easiest, right? 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So you only have to remember. So these were, again, we were asked to determine these. We had to look at the unit circle. We had to identify the reference angle. We had to identify the sign of the trig function in that quadrant. And then, okay, and then we look at trig equations, exactly what you asked me. So one more time, this is all I'm asking you to remember. Sine and cosine, nothing else. And 3 angles. Pi over 6, which is 30 degrees. Pi over 4, which is 45 degrees. And pi over 3, which is 60 degrees. And you should write this little chart. Once I hand you the final exam, you should write it somewhere in a corner. And put the numbers, 1/2, 1/2, the square root of 3 over 2, the square root of 3 over 2, and the square root of 2 over 2, and the square root of 2 over 2. Of course, you have to remember these points. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Which is the first coordinate? Well, it's the x-coordinate. What do we measure on the x-axis?
Or cosine.
Cosine. So this is always cosine, and this is always sine. So cosine, sine, cosine, sine, cosine, sine, cosine, sine. So if you want to determine, let's say, tangent pi over 3. I don't remember this. I don't care. I know that it's sine pi over 3 over cosine pi over 3, and then I copy it from here. The square root of 3 over 2 over 1/2 is the square root of 3. You don't need to memorize that. And I encourage you not to sit down and start memorizing tangent, secant, cosecant. No, there is no point in doing that. That's all you need, this and this. But yes, you have to remember that tangent is sine over cosine. You have to remember that cosine, that cotangent is cosine over sine. Secant, it starts with S, is 1 over cosine. And cosecant, it starts with C, is 1 over sine.
What about the identity sine squared plus cosine
Yes,
squared?
that is mandatory. That is the basic formula. Identity, yes. For any particular angle, sine squared plus cosine squared equals 1. Okay, allow me to finish what I wanted to tell you today. On Thursday, we're going to review everything we've studied in trig one more time with examples that you would see on the test, on the final exam. And on Saturday from 1 to 3, we have a review for everything. Hopefully, we don't need to talk about trig anymore, but if we do, we will. Okay? So what I wanted to look at, section 7.1 and section 7.2. So 7.1 and 7.2 are 2 theorems. We're not going to prove them. I don't like that. I don't like just putting formulas on your shoulders. But one of them we can talk about. The other one, it will take a little bit longer to prove. So they are called law of sines and law of cosines. Law of sines and law of cosines. Now, why do we even bother with these 2 laws or theorems? Is because they can be applied in any triangle. The triangle does not have to be right triangle. It can be any triangle. So that's why they're extremely useful. So I'm going to say in any triangle, not only right. And what are they? I would say quite easy to remember. Here they are. The notation of the triangle is very important. Here's the notation. Whatever triangle, if I denote this vertex A by A, B, and C, it is mandatory to denote the opposite side by the same letter, but lowercase. Since this is uppercase A, this must be the side denoted by a measure of lowercase a. If this is angle B, the opposite side must be denoted by lowercase b, and C opposite must be denoted by C. Assuming that this is the case, we can write two theorems. Here's the first one. Sine of angle A divided by the side opposite to it must equal, what do you think? Your wild guess.
Opposite.
Sine B over? Good. And must equal?
Sine C over.
Lowercase c. This is law of sines. It only has sine. So sine A, so this ratio must equal this ratio must equal this ratio. What are we going to do with this? Word problems in a minute. Now, law of cosines. Assuming, let's say, which is not the case, assuming, let's say, this is a right triangle, what will you tell me to write? A relationship between the sides. Assuming, yes, assuming this is the case. So you're going to say a squared equals b squared plus c squared. So the hypotenuse squared is the sum of the two legs, but this is not the case here. So minus 2 times the product of those two sides times cosine of the angle A. This is what we call law of cosines. What if cosine is 90 degrees indeed? What if it's not the case? But what if I would say to you, A is 90 degrees? How much is cosine 90 degrees? Cosine 90 degrees.
Zero.
Exactly. So I'm back to the Pythagorean theorem. So this is also called, when I learned it 100 years ago, it was not called law of cosines. It was called the Pythagorean theorem, but generalized. The generalized Pythagorean theorem for any triangle or to any triangle. It was not called law of cosines at that time. So now we call it law of cosines. Now, what if B is the right angle? It's not. But can you tell me the same thing for B now? B squared equals? There is no negative. On A squared and B squared, it cannot be any negative, right? It's the hypotenuse squared equals the sum of the squares. So it's A squared plus C squared, but this time, since B is not a right triangle, exactly, minus 2AC times, of course, times cosine B.
I'm so sorry. The first one, A squared plus B squared C squared. What is that? Minus 2?
Minus 2BC, the product of these, B and C. 2BC times cosine A. So now the last possibility, C squared will be, yes, I'm sorry, A squared plus B squared minus
2AB
times cosine, that's it. Now I would like to apply this in word problems. So on page 710, I'd like to look at problem, actually 711. Problem 50.
The last one, I'm sorry. Is
If this is
A
C,
squared
if
plus-
this is C, this is AB, AB, and cosine C. So a surveyor needs to determine the distance between 2 points that lie on opposite banks of a river. And here's the figure. I'm going to copy it. We are given A, B, C. We are given 62 degrees. We are given 53 degrees. We are given 300 yards. And this is point B. Okay, and that's where he is, right here. So the figure shows that 300 yards are measured along one bank. The angles from each end of this line segment to a point on the opposite bank are 62 and 53. Find the distance between A and B to the nearest tenth of a yard. So this is the question. I'm going to call it X. Now the question is this. How do I know which law to apply? How do I know when to apply law of sines? How do I know when to apply law of cosines? Personally, this is my suggestion, my recommendation. I will apply law of cosines when I have the sides. Because when I have 3 sides, like A, B, and C, and no angle, there is nothing I can do with law of sines. Because this will be unknown, this will be unknown, and this will be unknown, and I will not be able to determine anything. But if I have 3 sides, even if I don't have any angle, this will always work. I have this, 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 I have this. This is the only variable. Angle A. Same thing here. If I need to determine angle B or angle C, if I have all 3 sides, law of cosine is the only one that I can apply. If I have sides and angles, I can apply this. Depends. I have to look at what I have. And if I have sides and angles, I will not think of this. I will always think of this first. I may have to apply this, who knows, in some situations, but I will not think of law of cosines. So I will immediately think of law of sines. So let's write it. Can anyone dictate law of sines?
I don't. Maybe you should solve.
Sine of 62 over, I don't have this, so I'm going to call it y, over y equals sine 53 over x equals, and I can determine this because I know the sum of the angles in any triangle is 180. I have 62 and I have 53. So this angle, angle B, equals 180 minus 62 degrees minus 53 degrees. So how big is angle B? If you have it, how much?
65.
Excellent, excellent. Okay, so this is 65. So now I have one ratio to write. One more ratio to write.
Sine of 65 over 300.
I have to choose one proportion that has the unknown and just the unknown, and everything else is known. Can you recommend the proportion?
Sine 53 degrees. X.
Exactly. This is the proportion I need. What will I do here to solve for x? Cross multiply. Perfect. 300 times sine 53 equals x times sine 65. Final step before I put in the calculator. How much is x? How do I write it?
300
Very good.
sine
Divide by
53 over sine 65.
Excellent. Don't calculate anything, just we do one in one step. Okay, so I thought I turned this on. Apparently I didn't.
And we did that, we solved for x, we left the y alone because we don't need to know that.
We don't need x. We don't need y. They only want us to find x. So here's what we have, 300 multiplied by sine. Make sure that your mode is in
Degrees.
good. Okay, mine is in degrees, correct. So 300 multiplied by sine 53, close, divided by sine 65, close, and enter. So roughly 264.4. 264.4. Is it in feet? I forgot. No, it's in yards. And this is how we use law of sines. I would like to look at problem 12 on page 710. Let's look at 12. Solve each triangle. By solving a triangle, we mean find all angles and find all sides. Round length to the nearest tenth and angle measures to the nearest degree. Fine. So 12. A is 85. B is 35. And C, lowercase c, is 30. So uppercase A, 85 degrees, lowercase b, 85, 35, and lowercase c, 30. I have to draw a triangle. I have to denote the vertices by A, B, C. Can anyone tell us what are the measures of the given sides here? Yes, so I know that this is 85 degrees. I know that this is 35 degrees. I can find C, uppercase C, immediately.
60.
How much?
60.
Very good. 180 minus 85 minus 35. C is 60 degrees. Perfect. Now, what is the measure of BC if I have it? Do I have the measure of BC? No. This will be A. It's just unknown. What is the measure of AB?
Unknown.
Yes, it's the opposite of C, so it must be the lowercase. Good. And how much is the side AC? B, unknown. Perfect. So in order to solve this triangle, I have to present three angles, which I do have already, and three sides. So I'm missing two sides. Can anyone dictate law of sines? Because we have angles. If we don't have angles, I will think of law of cosines. So can anyone dictate law of sines?
Sine of C over.
Sine of 85 degrees over A
60.
equals
Sine of 35 degrees.
sine of 35 over B equals
Sine of 60
over.
over 30.
Good. Now I need, how many proportions I need to form in order to determine A and B? Two proportions. Let's start with this proportion. How do I determine B from here? Very good. So 30 times sine 35 equals B times sine 60. Final. How do I determine B?
5 sine 5.
So I have 30 times sine 35 over
60.
sine 60. We put it in one step in the graphing calculator. So 30 multiplied by sine 35 and divide by sine 60. Quickly, can anyone tell us how much is sine 60? It's the bottom angle. What would be its sine? Without looking. I start with 1/2. The up corner is 1/2, and this is the third angle. Square root of 3 over 2, right? Perfect. So I press enter, and I get roughly 20. So B is 20. Now it's up to you what you want to do. You can, what I would do this. But you can put in 20 and you can use this. It doesn't matter. So I prefer 30. Sine 85 degrees equals A times sine 60 degrees. Therefore, A is 30 times sine 85 over sine 60. I put in the graphing calculator. So I have, the only thing I need to change is 35 into 85. So it's 30 sine 85 divided by sine 60. That's why I used the same thing. So I got 34.5. So A is approximately 34.5.
Or would you say 35? Do you want us to round it up?
I'm fine. Yes, you can. So I did solve the triangle, meaning I can present all three angles, 85, 35, 60, and I can present all three sides. 34.5, 20, 30. The triangle is solved. All sides and angles are determined. I would like to look at, I'll come back to 712. I'd like to look at law of cosines. (42) on page 720. Is law of sines easy to apply? Just these three proportions? Okay. It's a very powerful law. We can do a lot with it, right? So I'm looking on page 720. Okay, problem 42. So let's read the problem. To find the distance across a protected cove at a lake, a surveyor makes the measurements shown in the figure. So we do have this, and we have A and B and C, and we are told that this is 65 yards, this is 80 degrees, and this is 105 yards. Find the distance from A to B. In other words, find lowercase c. That's the question. Perfect.
So I think you would use the one that has
C squared equals.
the cosine c, you have the angle.
Exactly. Equals. Very good. 105 squared. But minus 2 multiplied by 65 multiplied by 105 multiplied by cosine 80 degrees. Very good. That's it. All I have to do is punch it in. And this is law of cosines. So I have 65 squared. And I have plus 105 squared minus 2 times 65 times 105 times cosine of 80 degrees. When I press enter, I will get c squared. This is not what I want, though. So this is c squared, but I want c. What should I do? Take the square root. So I have second and the square root from the previous answer. And I press enter. So this is roughly 113.5. 113.5 yards. That's law of cosine. Let's look at problem 12 on page 719. Solve each triangle. Present all sides, in other words, and all angles. B, lowercase b is 4. Lowercase c is 1. And uppercase A is 100 degrees. I have to draw the triangle. I have to name the vertices. And I have to clearly identify and not make a mistake. So if I make a mistake in identifying the angles and the sides that I have, the whole thing will collapse. So can anyone tell us if we have this side? No, this is A that I don't have. Can anyone tell us if we have this side? 4. Can anyone tell us if we have this side? 1. And I have angle A, which is 100 degrees. So now I have this side and the angle in between. How do I determine A?
A squared.
Very good. 4 squared plus 1 squared minus 2 times 4 times 1 multiplied by cosine 100 degrees. So with a calculator, I will put in everything. And remember, this is A squared. I don't need A squared, I need A. So 4 squared is 16. 16 plus 1, I already have 17. Minus 2 times 4 times cosine 100. And I got 18, approximately 18, but I have to take the square root. So the square root of the previous answer, and I get 4.3 roughly. So A is approximately 4.3. So I have all sides. So I have lowercase a, 4.3, lowercase b, which is 4, lowercase c, which is 1. I have angle A, which is 100 degrees, but I need to determine the other ones. Now I can go back to law of sines. Let's say I want to use law of sines. How do I determine? And they're saying between 9 and 13, find the missing side only. Okay, it doesn't matter. So let's continue. We will not be able to determine this unless we did what you asked me to do last time. I want to just mention it. I'm not going to ask you to. So, yes. So sine, very good, over 4.3 equals over, very good. Okay, perfect. So now, this is the unknown. This is known, this is known, this is known. How do I determine sine B? Right, so I have to cross multiply. 4.3 times sine B equals 4 times sine 100. I have to solve for sine B first. Exactly. Perfect. So I have to approximate this. So 4 multiplied by sine 100. Close the parenthesis and divide by 4.3. So I know that sine is 0.9161. How do I determine the angle whose sine is 0.9161? What do I have to apply to this number? Inverse function. So to this number, I have to apply second inverse. I'm not going to ask you to do this because we haven't discussed inverse functions in detail. So as they said, just the missing side, not the angles. Okay, so sine inverse of the sine inverse of the previous answer. When I click enter, I get 66 degrees. So angle B is 66, and then I can determine angle C. Because I have 180 minus 100 is 80, and 80 minus 66 is
Why?
14.
Why are we not going more in depth in this?
Because this is part of 142.
Okay.
Yeah. That's why they put that in here, because it's part. So find the missing side only, not find the angles. Yes, they will be redone. Yes.
Than previous.
Yes, I believe that. I believe that. Okay, that's all I wanted to say. And now let's look at the graphs. Okay, and this is it. No more new material. And the graphs are section has sections 5.5 and 5.6. We're going to look at 3 graphs. We're going to look at the graph of a function called sine, a function called cosine, and a function called tangent. Okay? And then I would like to answer your question. I forgot what it was, number 3 or something. Yes, don't let me forget. Good, so let's start with sine. Okay, so let's do this together.
Flip it down.
Yes. So sine, cosine, and tangent. I'm going to take them sequentially. So for now, just write sine. So let's mark the units on the x-axis together. Okay? So I'm going to mark pi over 2. Same distance, pi. The next one will be
3
pi over 2. And the next one will be, and so on and so forth. Now I'm going on the negative side. What is the first one? Of course. Of course. What is the next one? Of course. And so on and so forth. Very good. Remember on the unit circle, sine is measured on which axis? Yes, it's the opposite, right? Opposite leg. So how high can sine be? How big can sine be?
1.
How low can sine be?
-1.
Right. So you don't have to draw this. For me, it's easier to graph. Okay, this is not an asymptote or anything like this. So it's not part of the graph. But I just lightly present this so I don't get the graph out of shape. So I have the positive 1 here and the negative 1 here, and I know the graph cannot go above 1 and it cannot go below -1. So sine is the first coordinate or the second coordinate? When I go around the unit circle, is it the first coordinate or the second coordinate? Sine. Second, of course. What is the value of sine at 0?
Sine, so
What is the value of y at 0? Because sine is y. 0. Perfect. What is the value of y at pi over 2? What is the value of y at pi? What is the value of y at 3 pi over 2? What is the value of y at 2 pi?
positive.
We got the picture. And now I go on and go on and go on and go on. Yes.
I don't understand. How you get this.
What is the value of y at this point on the unit circle?
Oh, okay. So it's
What is the value of y here?
1, 0, negative.
And I go on forever
Okay.
in any direction. So here's the graph of sine. And it goes on forever. That's why its period is 2 pi. So this is the graph of sine x. And yes, I can continue it forever. However, all we are interested in is in this. Complete rotation between 0 and 2 pi. Okay, ready? Cosine. We will be using this exact same units, and you already told me what they are. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and so on and so forth. Goes on forever. Now we're talking about cosine. Can anyone tell us whether cosine is the first coordinate or the second coordinate? First. So what is the first coordinate at this point? 1. What is the first coordinate at this point?
0.
Hang on. So cosine is on the x-axis.
Right. At 3 pi over 2. At 2 pi.
1.
This is the graph of cosine. Again, the same thing. I should have mentioned that. I got more courageous. This is not an asymptote. It should not be visible. So I put it in so I don't make a mistake and I don't go higher than I should. But this is nothing. So this is the graph of cosine x. Again, the same thing. 2 pi. One more graph, and then we'll just work on problems. I'm done. No more new material. So f of x equals tangent x. We're using the same units. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and so on and so forth. Yes? Okay. Can anyone give us a definition of tangent? What does tangent equal to? Now, like any ratio, this function has problems. When?
Cosine is equal to 0.
Exactly. Big problem. What does that mean? Undefined. Okay, let's come back here. Please tell me, where is cosine 0?
Pi.
Pi over 2. What am I drawing at pi over 2?
An asymptote.
Exactly. I have to draw also at 3 pi over 2. What am I drawing? A vertical asymptote. Good. Ready? What quadrant is this? Between 0 degrees, 0 radians and pi over 2.
Quadrant 1.
What is the sign of tangent in the first quadrant?
Positive.
Right, because sine and cosine are positive. Okay. What quadrant is this? Between 0 and negative pi over 2.
2.
Between 0 and negative pi over 2.
Oh,
4. So what is the sign? What is the sign of sine in the fourth quadrant? What is the sign of cosine in the fourth? So then, what is the sign of tangent in the fourth quadrant? And all I have to do is just repeat. This is just pi. The period of tangent is only pi. So this is f of x equals tangent x. I would like to graph these with a graphing calculator now.
What is just pi?
The period.
Oh,
As you see, I don't really need more than this. I see the entire graph between negative pi over 2 and pi over 2, which will be a period of pi. The same thing here. I see everything about this function between 0 and 2 pi. The same thing here, between 0 and 2 pi. But here, I only need pi. Pi over 2 here and pi over 2 here. Okay, your graphing calculator. So in y equals, clear? I recommend go to the mode and make it in radians, because we are going to put the same units we used for graphing them by hand. So that's why I need radians. So radians and enter. So y equals, let's put sine x and close the parenthesis. And now let's go to the window. I only care about 0 to 2 pi. 0, minimum. 2 times pi, maximum. Pi is right here. A scale of pi over 2, second pi divided by 2. How low do I want this graph to go?
-1.
Right, I'm going to go to -2 or -3 because I don't want it to be very low. I wanted it to be in the middle, but you're right. I don't need to see anything beyond -1. I'm going to say -3. How high can this graph go? 2, 1, right? But I'm going to put 3 with a scale of 1. So now I'm going to hit graph. And here's what we have. This is the graph of sine x. We want the same thing. Let's go back to y equals and change it to cosine. And press enter. I meant graph. Here's cosine. Exactly the graph we just had a few minutes ago. Now I want to graph tangent. So let's go to tangent, to y equals, change and put tangent. However, now I have to change the viewing window. All I want to see is, for x, how far to the left?
Pi.
Negative
-pi.
pi over 2. How high do I want it to go? Oh, I made a mistake. I'm sorry. That's my x minimum. -pi over 2. And this is positive. Okay? And I can go to -10 and 10.
X scale, what should that be?
I put, I can change that to, I can change that to pi over 4. So pi divided by 4. Here's the graph. Does this graph remind you of another graph from algebra part of this course? Yes, x cubed, very similar. Just remember that. However, x cubed does not have vertical asymptotes. It's a polynomial function, defined everywhere. This is not a function defined everywhere. So that's tangent. If you want, for example, to see as many or a few graphs of tangent, I'm going to change the viewing window to -2 pi to 2 pi.
This is kind of off topic, but X scale, what exactly is?
The units between that you see, the marks that you see on the x-axis. That's the scale. So as you see, this is the first tangent we just graphed between negative pi over 2 and pi over 2, it should have vertical asymptotes. So this is half of it, that's another 1, 2, 3. But what we had initially was just between negative pi over 2 and positive pi over 2. Okay, now we're ready to answer your question. What was it? I forgot. I can look back. It was problem 3 or something like that in 6. Was in 6 something. Oh yeah, I was in 5-6. Yeah, tangents. Yes. Got it. Okay, so let's take a look. We are given a very good question. We are given problems 1 through 4. So I'm copying this. Y equals. Oh, so sorry. Thank you so much. So we have tangent x plus pi over 2. We have tangent x plus pi. 602. So page 602. Y equals negative tangent x, and y equals negative tangent x minus pi over 2. Without looking at these graphs, I would like us to graph, and then we'll identify. Okay? So I know how to graph tangent. So y equals tangent x is this. Very similar to x cubed, but x cubed does not have asymptotes. So here's my graph. This is the graph of tangent. But now they want us to graph the first one, which is x, tangent x, plus pi over 2. What transformation is this? Shift where? To the left, how much? Pi over 2. So I will take this graph and shift it to the left pi over 2. From here, here. The asymptotes move with it, of course. So the new graph will be this. This moved here, this point moved here, and this moved here. So here's my graph. Can we identify this graph, which is tangent x plus pi over 2, anywhere?
It repeats itself.
Is it 1? Is it 2? Is it 3? Is it 4? Of course, 3 and 4 cannot be because they are not in this direction. So it must be either 1 or 2. But it cannot be 1 because 1 crosses at the origin. So it must be 2. Would you agree? Although they want to be tricky. They don't show us what we graph, the portion we graph. But it's very clear that it's number 2. Are we okay with that? Okay. Don't look at the graphs. Let's continue. So this was identified. Now, how do I graph tangent of x plus pi? Same thing, but this time, this does not go pi over 2, but it goes pi. But if it goes pi, then it will be this. And it will be this. And it will be this. That's always true for trig functions. So which one will it be? So I moved this portion here. But they go on forever, left and right. I only graphed one piece. But I should have graphed this and this and this and this and this and this. So once I move this here, there is another one coming from the right. And there is another one coming from the right. And there is another one coming from the right. So which one will be this? Number 1.
Is that because it's only because it's pi that does that?
Because I moved everything pi to the left. This one gets moved as well pi to the left. The next piece gets moved to the left pi as well. Exactly. So that's because it's pi. So that's number 1. Or tangent x plus pi. Okay, so let's look at the third one. How do I graph this? And what transformation is this? Negative tangent x. Exactly. Absolutely. So here's the graph. If this is the graph of tangent, the portion that is positive, it becomes negative, and the portion that is negative becomes positive. So this is nothing else but negative tangent x. So is there a graph like that? Number 4. Although we know the answer, let's analyze without looking this. Here we have 2 transformations. First transformation, I have to shift tangent to the right pi over 2. So this will go here and then flip. So it will move from here, and then flip. So I have to do it in 2 steps. So first, I graph tangent. So here's tangent. Then I move tangent to the right, pi over 2. So the first function is tangent. The second function is tangent minus pi over 2. But now the third transformation is telling me to do what? Yes. So this is here, and this is here. Which graph is this? Better? That's all I'm asking you to do. Just identify these graphs. Yes?
I'm just confused when it's move over pi or move over pi over 2 on the x-axis.
So this is pi over 2. This is pi over 2. Right? So if I move it to the left, pi over 2.
So you're just moving it where pi over 2 is?
No.
When we graph them?
No. So I'm tangent, and this is negative pi over 2, and this is pi over 2. I'm going that way, pi over 2. Pi over 2 goes to 0. Negative pi over 2 goes to negative pi.
Okay.
Yes.
But now if I go that way, pi,
You have to go all the way
exactly.
like farther.
Negative pi over 2 goes to, forgive me, positive pi over 2 goes now to negative pi over 2 because this distance is pi.
Okay, so it's not like what we did before, like you're moving 2 spaces over. It's like you're moving to where it would be.
I have to move this from positive pi over 2 here because that will be the distance of pi.
Okay. Because pi is a farther distance than pi over 2.
Correct. Very good. Any questions? I have about 10 minutes. I would like to go back to finding values of trig functions using the reference angle. And please choose. Yes.
I have a question.
Yes.
On 560, number 29, like how do you find the denominator for sine and cosine?
Can you give me the problem?
Tangent, it was tangent, I forgot that symbol.
Alpha, theta, it doesn't matter.
Theta,
Okay.
Tangent theta equals negative 2 over 3. And then it says sine theta is less than 0.
Very good. So we want to find all trig functions.
My bad, I meant greater
Okay? No problem, no problem. So we are given tangent, and we are also indicated, we are told that sine is a positive number. And we are asked to find sine theta, cosine theta, cotangent theta, secant theta, and cosecant theta. Okay? Ready? First of all, I start with a unit circle. Where is sine positive?
At the first quadrant, second quadrant.
Right, because sine is measured, is the height, so it's measured on the y-axis. Excellent. Where is tangent negative?
On the third quadrant.
Careful. So when both sine and cosine have the same sign, tangent will be positive. Where sine is positive and cosine is negative, tangent will be negative.
Yeah, the second.
Very good. So here and here. Now I have to pick the quadrant in which both conditions are fulfilled. Which conditions? Tangent is negative and sine is positive. Which quadrant is that? 2. So I'll say theta in 2. Why is this extremely important? Because I don't know the sign of sine, cosine, cotangent, secant, and cosecant. This will tell me now. So I know that when I determine sine theta, it will be a positive number. When I determine cosine theta, it will be a negative number. Tangent theta I already have. Cotangent will be a negative number, is 1 over tangent. I can already write it right away. Secant theta is 1 over cosine. If cosine is negative, then secant is negative. And finally, secant theta, positive. So once I establish this, I immediately write these symbols. So first the unit circle. Secondly, I identify the quadrant. Then I will know immediately the signs. Yes?
So the last one, secant, cosecant.
No, I made a mistake here. It's
So
cosecant. I'm sorry. Yes. I wrote sine by mistake. Sorry about that. Very good. So now,
So just like how you find sine or cosine, you set it equal to something. Like you know how you would do sine squared, sine
Yes.
base squared plus.
yes, but I'm not there yet. Okay. So I only have tangent. Okay. Now, did I assign a problem like this, or was it in the
That's in the book. There's a practical problem.
among the list of recommended problems or not?
I'm not sure.
That's okay, because I need to discuss something else before I finish this. And here it is. What did I say was the most important identity in this trig? That sine squared theta plus cosine squared theta equals 1. Let's divide both sides of this equation or identity by sine squared. How much is sine squared over sine squared? 1 plus. How much is cosine squared over sine squared? Very good. How much is 1 over sine squared? It's 1 over s. Co. Very good. Okay. For the same identity, I would like you to divide both sides by cosine squared. Sine squared over cosine squared. Cosine squared plus divided by cosine squared. And 1 divided by cosecant squared. These are super important, and without this, I will not be able to get that. So that's why I hope I did not assign that, because this is what I'm doing it right now. So now I have tangent. I have cotangent. I have to use either this or this, whichever you prefer. Since we are given tangent, let's use this. Tangent squared. When I square negative 2/3, what should I have?
4.
Excellent. Plus 1 equals secant squared, which is 1 over cosine squared. I need the least common denominator, which is 9. I have 9, so this is 13 over 9. equals 1 over cosine squared. So how much is cosine squared? In a proportion, I'm allowed to flip.
13.
Exactly. 9 over 13. So now I take the square root from both sides. But remember, cosine must be negative. So please take the square root and tell me what to write. The square root of 9 is, and the square root of 13, I'm going to leave it as is. So this is how I determine 3 over the square root of 13. And then the rest, it's yeah, history.
That was page 569. 20.
What's the problem?
No, that was 29.
Okay. So yes, once I have cosine, I know how to determine sine from this identity. And once I have cosine, I have a secant, which is the square root of 13 divided by 3. And once I have sine, I will determine cosecant. Yes. So from this identity, we come up with 2 other identities that are extremely useful when I'm not given sine and cosine. On the final exam, you will be given sine or cosine.
So do we need to know that I'm lost? Is this something we need to
So
know?
from this equation, I divide both sides by sine squared. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And 1 divided by sine squared is cosecant squared. So from this identity,
It's not those problems.
then you get this identity. Same thing here. If you divide both sides by cosine squared, you get this identity. So all these 3 identities go together. Why my colleagues decided to split them, I don't know. But when I present this, I present all 3 together. These 2 come from this one. Any questions? Any questions? Very good problem. But I will give you sine and cosine, so you don't have to use these 2 identities. Okay. We still have 5 minutes, so let's work on one more problem. I would like to look at a trig equation. So I'm going to ask you to solve sine x equals negative 1/2. Walk me through the steps.
Okay, well, it's gonna be either quadrant 3 or 4, because it's negative, sine is negative.
Very good.
And the reference angle would be
You don't have to look. It's the first
30
angle.
degrees.
The first angle is the first number, 1/2, right? So first of all, I look at the unit circle. Excellent. I know that sine is negative in these 2 quadrants. I already know the reference angle, which is this, indeed 30 degrees.
as well as that.
Yes. So then I know I have to give 2 answers. Well, infinitely many, but I have to give 2 answers. This is one angle,
Plus 30,
and the other one
and
is this. Good. So then, x equals and x equals. You can give, yes,
210 plus 360 times k.
perfect. What is the other option? 330, very good. Plus, that's it. And no, I will not ask you to determine or solve the equation this. No. Because we have not studied, this is not part of this course,
Did
the
we
inverse
go-
function.
I'm sorry, did we go over solving for the reference angle on the calculator and then determining if you have which quadrant it is? It was on the homework, or on the suggested homework.
Can you remind me the problem?
I think it's page 560, 61.
560.
Oh yeah, I'm sorry, 694, 85 through 90 all.
You said 85 through 90 on 694. Let's take a look. 94. 85. Yes, I truly believe that this should not be part of this course, but let's do it. I picked 86. Did I select a problem like this on the homework?
It was,
No, not on the
85
recommend.
through
Not on the recommended. Okay,
It's 85 through.
good. So in order to solve this equation, we will have to do what? What will we have to do to this number?
I thought you just had to use inverse function.
Right.
And it would give
Yes,
you one
but we
answer,
haven't-
and I went to
True,
that
but we
and
haven't discussed the inverse function. It's a long theory behind the inverse function. We have to graph it. We have just tell you apply the inverse function. I don't think it's
So I thought it was as easy
Yeah.
as just putting one number
That
in,
is.
and then I went to
That
check
is-
it, and
that
there were
is-
two different numbers.
no. It depends whether you're
It's quadrature,
no.
or I mean,
Of course, but also make sure that you're either in degrees or in radians. So depending on what you're getting. So of course you're going to get two numbers, one in the first quadrant and one in the second quadrant. But first of all, let's look at the reference angle. And this will be the reference angle, which is roughly 48 degrees. So on the unit circle, this is 48 degrees. And this is exactly what we did. And this is the other angle. And of course, it's still 48 degrees here, the reference angle. So this equation has two solutions, 48 degrees plus 360K, if you want. And the other one is 180 minus 48 degrees, 132. But there is a contradiction. Here, they want us to find the inverse function, apply the inverse function. But here, they tell us, find only the missing side. So don't apply the inverse function because we haven't discussed it, really. So I don't think that this should be part of this course because, as I said, we haven't discussed it yet. We don't know how the inverse function looks like. We don't know where it's defined. We haven't discussed it. So I'm not going to put something like this. So we'll meet again on Thursday. Please bring all your questions. All I'm going to do, yes, and homework. All I'm going to do on Thursday is review what we just covered from Trig from the beginning till today. Yes, Abu?
Can we tell you our choice about the?
I think it's a good idea. I truly believe that we should only have 3 tests and have the final exam, and I will replace the lowest test grade with the final exam grade. Are you okay with that? Everyone? Yes? So I will remove test 4.
So there won't be, the final won't count as 2 tests.
No, but it will count as 2 tests for people who have a low test grade. So let's say somebody has a 50% on one of the 3 tests and gets a 90% on the final exam, then I will replace the 50% by 90. If somebody gets a lower test grade than the other 3, I'm not going to replace anything. That's only if it helps your grade. Is that good enough?
Yep. Yeah.
Okay, I will see you on Thursday. And if you have time, please come on Saturday so we can review everything else.
This room?
Yes, in this room, I reserved it from